Hello students, today we're going to talk about area story problems. Area story problems can be solved by any of the four methods using quadratic or using for solving quadratics. However, it is important we try to find the best one that works in that situation. So we kind of have 6 steps here that we're going to just outline real quick. Step 1, when you have the story problem, you read it, and then I would draw a picture or draw the rectangle to get things going. So over here I kind of have a sample one. It doesn't have to be perfect. It doesn't have to be drawn to scale. But typically label, Then step 2 is to label on that picture a length and a width. And again, it doesn't matter if it's drawn to exactly look like whatever the scenario is. It's just important that you can kind of see one is the side of a rectangle. All right, so label a length and a width. And do that after we've drawn the rectangle. So step 3. Now we're going to try to set up one of the sides using whatever sentence that has the length is, whatever it might be. So if it says the length is, emphasis on the word is, so the length is equal to or twice the width or whatever it might be. So we'd say the length is equal to blank. Now, or it could also be they give you a sentence that says the width is. Now typically you only have one of these. So whichever one you're given, that's the one you want to set equal to and then fill it in. The other one is just going to be a variable by itself. All right, step 4 is going to be to multiply the two sides using the one variable. So once we've written something in here for L, if it's twice the length, then we'd put if the length is twice the width, we would put 2w there and we'd multiply 2w times w. Okay, so this is just a sample one. This is not one we're doing right now. I just wanted to give you kind of a picture to go with these steps. So multiply the two sides using one variable. All right, in this case it would be w and 2w, so we wouldn't have an L. And then we're going to set equal to the given area. So you will be given the area of the figure in the story problem. Set equal, to the area given in the story problem. And then step 6 is going to be to solve using the best method. So any of the methods could work, but sometimes one is better than the other. You always have quadratic formula to fall back on. So solve using best method. All right, so there you can pause it to update those steps if you'd like. We're going to go ahead and move on to number 1. So for this one, find the dimensions of a tall rectangular poster with an area of 10 square feet. So there they've given you the area. And if you like to underline things, by all means, underline. You do not have to. Some people like to underline more than others. So all right, the given area of this rectangle, and again, even though it says it's a tall rectangular poster, you don't have to draw it perfect. You just need to label the sides. So I draw that. I've got a length and a width, right? The area is 10 square feet, so maybe make note of that. And it says if the length is, so the key word there is the word is. You don't have to circle it, but I'm going to do that for right now. Length is 8 more feet than 2 times the width. So the length is L equals 8 more feet is the plus 8 than 2 times the width. So 2w would go there. So now I've got this to replace the length, and I'm going to multiply w times 2w plus 8. So w times 2w plus 8. And that is going to equal, we're going to set that equal to the total area, which in this case is 10. All right, so I go ahead and distribute this. I've got 2w squared plus 8w is equal to 10. I need to set it equal to 0 if I'm going to, more than likely I'm going to do quadratic formula, or factor. Typically those two will both work. This case, I'm going to show you one where we can do this by factoring. So 2w squared plus 8w minus 10 is equal to 0. We could do quadratic formula. However, I recognize they all are even. So I'm going to divide the whole thing by 2, bring that up here, and I'm going to have w squared plus 4w minus 10 is equal to 0. When I do that, I recognize, hey, I could I could factor this. Oh, sorry, this should be a 5. Scratch that. So minus 5. So I notice factors of 5 that combine to 4, I could do that. So factors of negative 5, I've just got 1 and 5. They could definitely combine to 4. It's a positive 4, so positive 5 with a negative 1. So I factor this into w minus 1 times w plus 5 equal to 0. So I would set w minus 1 equal to 0, add the 1. I get w is equal to 1. Now, I actually get a second one, but on this one I would get negative 5. W plus 5 equals 0. When I subtract the 5, I can't have a negative distance for a side length, so that one's out. So my width over here is going to equal, so I'm running out of space, 1 foot. So that is part of my answer. And then I got to plug this back in right here and in order to get the length. So that would be 2 times 1 plus 8. So my length is equal to 2 plus 8, which is 10 feet. So there you go. So it's 10 feet tall with 1 foot wide on the banner or the poster. Okay, so that's number 1. All right, let's go to the second one. This time a width of a rectangular swimming pool. So again, we just draw a generic rectangle is good enough here. Sorry, my paper moved there a little bit. And we label it with the length and the width. Again, it doesn't matter which one's which as long as you got them on opposite, or not on opposite sides, on different sides. All right, this time the width of the rectangular swimming pool is, so this time the width is equal to 15 less. So that's 15 less. So I kind of work backwards here. This is one of our backwards phrases from writing equations. 3 times the length. 15 less than 3L. So 3L minus 15, we're going to take times L over here. L times 3L minus 15. And that is equal to the area of the pool, which is 42. So we set it up like this. We're going to have to do distributive property. We've got 3L squared minus 15L is equal to 42. We can subtract the 42. When we do that, we get 3L squared minus 15L minus 42 equals 0. And then, now, we could do quadratic formula. However, to save time, 3 does go into all of those, so I could factor a 3 out, much like I did on number 1. And I'm going to go with L squared minus 5L minus 14 is equal to 0 now. So that is definitely something I can factor. We get factors of negative 14. I've got 1 and 14, 2 and 7. I want to use 2 and 7, and since it's negative b, the larger one is negative. So I'm going to have L plus 2 with an L minus 7 is equal to 0. So my options for answers are L plus 2 equals 0 or L minus 7 equal to 0. I subtract 2. L is going to equal a negative 2, or I add 7, a positive 7. So has to be this one because we can't have a negative distance. So if L is equal to 2, I need to plug it in over here. So I'm going to do 3 times 2 minus 15. Whoops, I got in a hurry there. Sorry, 3 times 7. 3 times the 7, not sure. We'll blame that one on being close to spring break here as I'm making this video. All right, L is 7. So 3 times the 7, we get 21 minus 15. So W is equal to 6, and that was feet. So it's going to be 6 feet wide and 7 feet long, according to this question. So there we go. That is the front side. Feel free to pause and keep up if you need to. We're going to go ahead and go to the back. All right, plastic case that holds the old CDs has a standard length 4 centimeters longer than its width. So again, just draw the generic rectangle. We label a length and a width. All right, and then on this one, it says has a length 4 centimeters. So we could say the length is 4 centimeters longer than its width. Okay, so the length is, or the length has 4 centimeters more than its width. So I'm going to put W plus 4. If you put 4 plus W, that would work too. All right, so we got to set this one up. We're going to have W times W plus 4 is equal to 77. We go distributive property here. We get W squared plus 4W is equal to 77. And we subtract that over so that we can set it equal to 0 and possibly do quadratic formula or factor. All right, so this one actually, if we check, one factor I know of 77 is 7 times 11, and that has a difference of 4. So I am actually going to go ahead and factor this into, if I look at factors of 77, I got 1 and 77. I also know 7 and 11, although there might be others. I'm going to go ahead to there. It's positive 11 with a negative 4 because that will give us a positive 4. So W minus 7, W plus 11 are equal to 0. So my solutions here, W minus 7 equals 0. I'm going to add 7. Okay. And then I'm going to have W is equal to 7. This one would get me a negative, so the width is 7 centimeters. All right, for this other one, we're going to plug it back in. So it's going to be 7 plus 4 for the length. All right, here, keep this separate. So the length is equal to 11 centimeters there. All right, so there you go. There are the first 3. Now the last 2 you can set up and solve using quadratic formula. We will go over those in class, and thank you guys for your time. Have a great day.